So trig functions are really just, you're going to hear me say trig and right trig, not trigonometry or trigonometric, just because it's faster and it's pretty common. But trig ratios, there's 3 types, and they all have to do with the sides of the triangles. And for our purposes in geometry, they have to be right triangles. I will say in Algebra 2 you're going to do some other stuff with trig, but that's not what we're doing in geometry. So in geometry, you have to have a right triangle to use trig, okay? And it all has to do with where the sides are in reference to one of the acute angles. Now, one of the sides we've already covered this year, and that's the one across from the right angle. This one's always called the hypotenuse. Okay, that's not new. That's something we've done since we started talking about Pythagorean theorem. Okay? Now, when you see a right triangle, you know these other 2 angles are acute angles. They have to be less than 90 and more than 0, right? So they're usually just going to be talking about one of them. And a lot of times they'll use this symbol. It's not a 0, but it looks like a 0 with a line through it. It's a Greek symbol. You know how we use symbols all the time in math. It's called theta, but really all it means is that's an angle. Okay? So if this is the angle we're talking about, then this side here, it's right next to it. Okay? So we call this one adjacent. The word adjacent, we talked about adjacent angles earlier in the year. Adjacent means next to. Okay? This one over here that's across from it, we call it opposite. So opposite means across from, adjacent means next to. Now, the hypotenuse is next to it also, but we never label this one adjacent because it's always the hypotenuse. That never changes. But just so you know, had we been talking about this angle up here instead of this one down here, then this one would have been the next to. This one would be adjacent. And this one would have been across from, so we would have called this one opposite. Okay, so it depends on which angle you're referring to in the problem, which one of these labels they get. Hypotenuse never changes. This one stays the same no matter what. Okay, so there are 3 types of trig ratios that we'll use in geometry. They're really 6, but we won't use the other 3 in geometry. They use them in Algebra 2 next year. But we have what we call sine, we have cosine, and we have tangent. Now this is the shorthand version for it. It's not sin, cos, tan. It's sine, cosine, and tangent. But that's the letters. I'm sure you've seen those on your calculators. Not just on the calculators that you've used in math classes, but even just on your phone. Let me pull up my calculator just to show you. I know, and if you have an iPhone, yours might be different. But when you look at this calculator on my phone, you don't see those words. But if you turn it this way, sine, cosine, tangent. So, for those of you with the phone, for a second, not to play your game or text, pull out your phone and see if you turn it sideways. Does yours say sine, cosine, tangent? Your buttons look a little different, I think, if you have an iPhone, but you should still see the buttons, sine, cosine, and tangent. Anybody not see them? Alright, now there is two things that's really important about it. A, you're going to have to use the right one, and I'll show you which ones are which. B, see how up here at the top of my screen it says DEG? That means degrees. That's how we normally measure angles. But there's another way to measure angles called radians. That's what this rad button is. It's not rad, it's radian. Radian in degrees. See how I can go back and forth between them? We are going to use radians next unit. But to do trig, it has to be in degree. So if I started typing in trig right now with that says radian, I'm going to get all the wrong answers. It'll give me answers, and I might not even notice that I'm in the wrong mode. But if I'm not in degree mode, every answer will be wrong. So it has to say degree. Okay? Now, if you're using the calculators up here, how you change it isn't as simple as hitting that button. But I can show you how to change it if you're using one of the TI Inspires, or if you had a TI 84 or something that you already owned. They're in different places, but you always have to put it in degree mode, or it will not give you the right answer. Ever. Okay? Y'all with me so far? Alright. I'm going to show you how to put it in the calculator after we cover what it is. So for sine, cosine, and tangent, it's always of an angle. By themselves, those words, they have no value. You can't just get a value of sine. If you put in sine in your calculator and hit enter, it's going to give you an error because sine is a function. It has no meaning all by itself. It has to be paired with an angle. Okay? So this angle can be anything between 0 and 90. It can't be 0 or 90, but it can be, anything above 0 but below 90. Okay? Because this is a right triangle. So far, y'all good? Okay. So the three ratios that you have, remember ratios are fractions. Okay? The sine is always going to be whatever the opposite value is. So whatever this side length is, it's going to be divided by the hypotenuse. Okay? Let me zoom in a little bit. Make that a little bit bigger. Sorry about that. The cosine is always going to be whatever this side is, the adjacent, divided by the hypotenuse. And then tangent's always going to be whatever the opposite is, divided by the adjacent. Okay? Now, that's actually not necessarily too hard. The thing is, because it's only three things, but I'll be 100% honest, I would still get them mixed up today if there wasn't another way to remember it. Because while they're not difficult and it's only three things, they're really easy to get all mixed up. So do y'all remember when you first learned PEMDAS? There was a way that you remembered the order those letters went in? Or your order of operations? You learned PEMDAS because it was the letters meant something. And y'all remember, please excuse my dear Aunt Sally? That was how you remembered how to spell PEMDAS. So we have one of those. It's a mnemonic device. And it's called SOHCAHTOA. Okay, SOHCAHTOA. What this is a mnemonic device just like PEMDAS. See, if you look, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. So this one word will help you remember all of these. And I will also tell you, just like PEMDAS had the way to remember how to spell it with being, please excuse my dear Aunt Sally, I didn't make this one up. I didn't learn it when I was your age, but another teacher several years back shared with me a sentence that you can use to help remember that. It is slightly inappropriate. I always go ahead and say it because I would rather risk saying something a little bit inappropriate but give you a tool to help you remember than being like, oh, I can't say that because it's a little inappropriate, and then you can't ever remember how to spell that word. Okay, so it's silly, and I will even say if you can come up with a better one that I can use that's not inappropriate, that's easy to remember, I will give you 5 bonus points. But the one I know that somebody else taught me was some old hippie caught another hippie tripping on acid. So I'm sorry that there is a drug reference, but if it helps you remember it, it's worth it to me because you need to know it. Okay? But if you can come up with a better one, bonus points. Okay? But it has to be one we can remember. If you make a sentence that doesn't make sense, we'll never remember it. All right. So far, are you with me on the ratios? Okay? This order matters. If you put the hypotenuse on top and the adjacent on bottom, you're not giving me the cosine. Okay? It won't find the angle the way you think it will. All right? So these are the basics. Literally, that's almost all that there is to teach you, but of course you got to know how to use it. Yes?
How are the first one and the third one different?
This one, they both have opposite on top, but this one's hypotenuse on bottom, this one's adjacent on bottom. So see how the hypotenuse is longer than the adjacent? So they'll always be different numbers. Okay? The only time they can ever be the same, like the same number, is technically the sine and the cosine could be the same value if these two were the same length. But to be honest, if these two were the same length, wouldn't you have just done a 45, 45, 90 and not bothered with this new method? Because remember, that one's a short version. Now, another thing about sine, cosine, and tangent, when you get values for these, you're never going to get an exact number unless your angle happens to be a 30, a 60, or a 45. You're not going to get an exact answer. Okay, they're going to be an angle or a side length that the decimal just keeps going. This is one time where you actually have to round. You'll round to however many places your directions say. I believe on your assignment it says the 10th place, so that's one decimal. But sometimes it'll say to round to the whole number or to round to the 10,000th place, which is 4. Be lucky that your calculators now do this. When I was in school, in the back of your textbook, they had trig tables. And it had every angle from 0 to 180, and then it had the values for sine, cosine, tangent, and then the other ones that you'll learn next year. And then if your angle was, say, 70.5, you had to find the value for 70, find the value for 71, and then round them. So y'all can just type it into your calculator. So that's good news. All right, so let's put some numbers on this so you see what you actually do with it. All right, so if I told you that this side was 6, and this side was 8, and this side was 10, then how we would set these up, I will have to zoom out a little bit so you can see what we're writing, is if I was going to do the sine of theta, what value is the opposite? 8. What value is the hypotenuse? 10. Now, does 8 over 10 reduce?
No.
Yeah, they're both even, right? So can't you reduce that by dividing by 2? What is 8 over 10 reduced to? 4 over 5. So that's the sine of theta, 4 over 5. Okay. So the cosine of theta, what value do we put in for the top? And for the bottom? The 10. What is 6 over 10 reduced to? 3 over 5. All right, one more on that kind. Tangent of theta. What should go on top? And what should go on bottom? Okay, what is 8 over 6 reduced to? 4 over 3. So these are the trig ratios. Now remember, ratios are just fractions. Now that being said, what if we weren't using theta? What if we were using the other angle? Is it too light? Let me zoom in a little bit. I'll use a darker color next time, sorry. Leave it there for a second where you can you see them now that I made them bigger? I'll try to use a darker color next time. So what if we were not using the angle where the theta is? What if we were using that angle at the top? Okay. Up here. So what if instead of theta I used alpha? Y'all remember, these are just symbols. They could be X, Y, they can be anything. But if I made this right here my angle, is this one opposite of it?
No, that would be the adjacent.
Yeah, this one would be the adjacent now. This one, it would still be the hypotenuse because it's the hypotenuse. But this one over here would have become the opposite, wouldn't it? So if I wanted the sine, cosine, and tangent of alpha instead of theta, and again, these are just Greek letters, but if I used all X's and Y's, then you would never have heard of them, and if you ever see them on assignment, it'll confuse you. They're just symbols that stand for a value, okay? Just like a variable. But if I wanted the sine of alpha, sine is still opposite over hypotenuse, but what would that be now? Yeah, it would be the 6 over 10, which reduces to what? 3 over 5. If I wanted the cosine of theta, I'm sorry, of alpha, I apologize. Cosine is still adjacent over hypotenuse, but what would it be now? It would be 8 over 10. Yeah. And that reduces to 4 over 5. What do you notice about the sine and the cosine? They're not the same values, but they switched, didn't they? See, what was the sine of theta is the cosine of alpha. What was the cosine of theta is the sine of alpha. So let's see what happens to the tangent, because it doesn't have one to switch with. So if I do for tangent, opposite over adjacent, we're in pink right now. What's the opposite? 6. What's the adjacent? So what's 6 over 8 reduced to? 3 over 4. So obviously the sine and the cosine switched. See the values? But what happened to the tangent? It flipped. That happens every single time. Okay? So if you ever are doing it and you're using the wrong angle, the answer you put for sine is going to be the cosine answer, and the answer you put for cosine is going to be the sine answer, and you'll have your tangent upside down. So it matters what angle you're using. Okay? It will give you the wrong answer if you use the wrong angle. Okay? This is the overview for the trig ratios. However, we haven't solved anything yet, right? This is just what it means, what the parts are. So I'm going to go over how to solve for a side and for an angle in just a second. I'm going to put it on a different video so one video isn't too long. Okay?